Hello and welcome back again. We're continuing our short series for preparation for our upcoming Wizari exam. So we stopped at chapter 6 questions, question 46, and we're going to continue from there on. Let's see. How many glands in the male reproductive system produces alkaline secretions that help neutralize acidity? See, if we know the number of glands that are in the male reproductive system, then we don't have a problem. The common answer of how many glands we have, they say 3. That's the most common answer. No, you have 3 types. You don't have only 3. Let's see what are the types. Remember, what did we say? Types. The first type, second, and third. The first one, we have prostate. Prostate gland, okay? And then we have seminal vesicle. Then we have the bulbourethral or Cowper's gland. Let's write down Cowper's gland. See, 2 of these are creating alkaline solutions for different reasons, okay? Now, the Cowper gland creates the alkaline solution to clear up the traces of the urine, while the prostate gland creates alkaline solution to neutralize the acidity of the female organ for the sperms to survive. As for the seminal vesicle, it is a solution, a combination of multiple things, but most importantly, it has the sugar in it for the sperms to use it and survive. But how many of these do we have first? See, we have 3 types, but the prostate gland is 1 in number, while these 2 come in pairs. We have 2 of these, 2 of these. The total is 5. We have 5 male glands in the male reproductive system. It's not 3, it is 3 types, like we said. Among these, we said that this one creates alkaline solution. Here, it didn't specify for what reason, so we're going to choose both of them. How many? We ended up with 3 in total that create alkaline solutions for neutralizing the acidity. This is our answer. When I was it was possible for me to choose 1 or 2 if they specify what it is used for. If it's for like the female reproductive organ to neutralize it, I was going to choose 1 as the prostate gland is 1. If it was for neutralizing the traces of urine in the penis, then the second one, B, is going to be our answer. According to the requirement, we're answering. If it didn't specify, we're going to combine them according to what is given, like we said. Good. We're warming up. Question 47. Here, analogy, you should find pattern. Insulin, a hormone, pancreas, endocrine cells, it's where it's produced. It says, I don't see any more hormone. I'll consider this as a product, and this is production side. Okay, so the product should be on this side and the production should be on the other side. Let's see, we have testosterone or sperm, okay, between these 2, which is matching with its production side. Is testosterone made by anterior pituitary gland? No, testosterone is made in the testes, okay? So this one is out. The sperm is created in the long coiled tubule. Okay, I know sperm is made in the tubules, but is it epididymis? Epididymis is just where the sperms are temporarily stored there to complete their maturation. So it's not where it's made. It was made before it reaches the epididymis. As for testosterone, again, it says cells located between the seminiferous tubule. If we're drawing a testes like that, this is the scrotum, there's so many of these small tubes, okay? These are the seminiferous tubules, okay? There are so many of them. The testosterone is made by the cell located in between these, okay? Not inside the seminiferous tubule. So this one is right, but let's hold our answer and try to figure out what's the last one saying. It says sperm is created in the lining of the scrotum. This is scrotum, is just for covering, okay? Since the testicles are coming down outside of the body, the scrotum is a protective shield outside it, but it's not made it here. This is seminiferous tubule. It is appearing to be very thin and there is nothing inside it, but under microscope there are so many cells that create the lining of these, and the sperm is made of the lining of seminiferous tubule, while the testosterone are made by the cells between the seminiferous tubule. Got it? So they have to be close because testosterone makes sure that the testes create the sperm and it's continuing. Without it, you cannot have like enough sperm production. That's why they're close by. The answer is C here. Good question. Let's go for 48. It says pregnancy begins at which part? While gestation starts at. So the start of gestation and pregnancy is different. Usually these two, or commonly between people, is used alternatively. People think pregnancy and gestation period is the same thing, but no. Pregnancy is happening 1 week after gestation. Okay. That's okay. 1 week after. Got it? Almost 1 week, something close to that. Because gestation starts exactly where the egg is fertilized. The moment you have zygote, gestation starts. Okay, and it's a period of 9 months and more. Got it? So at fertilization, although we have one fertilization here and I could choose it immediately, but let me check. What is pregnancy? Pregnancy, okay, it's more confirmed that the baby now is ready to grow and to become fit as an embryo. So it should fertilize or implant. Like we said, if gestation is fertilization, pregnancy is 1 week afterwards, so it cannot be fertilization. It's actually implantation. We're going to choose D. Remember, gestation is the whole period from fertilization till the birth. As for the pregnancy is 1 week afterwards until they give birth. This is why we chose D. For question 49, it says, where are the target cells of FSH? Okay, FSH, it is follicle stimulating. All stimulating hormones come from pituitary, but which side? It's the anterior. Anterior pituitary creates it to regulate other glands so that the glands are producing other hormones that's going to complete the mission. As for FSH, since it says follicle, and we know follicle is a structure in the ovary where the ovum is in the middle, this is the egg, and there's like smaller ovary cells surrounding it together. We call them the follicle. But does that mean only females have it? Let's figure it out. What we need to know is that FSH primarily works on gonads to make more gametes, okay? Gonads. This is S. Gonads are site of production of gametes, and where we create these? In ovary and in testis, okay? These two are creating the gametes, which are sperm and egg. Gonad is a common name for ovary and testes, site of production of gametes. Good. Is the uterus part of the gonads? No. Uterus is an organ that houses a baby. It has nothing to do with creating egg. Even if a female was deformed and was born without having a uterus, that doesn't mean they cannot create ovum and eggs, okay? Because these are created in the ovaries and they are different. This is not the target cells here. What about the follicle in the ovary? Yes, okay, the follicles in the ovary, they are getting targeted by FSH and create more estrogen to make sure to prepare the egg in order to ovulate. This one is right. What about testes? Of course, it's gonna affect the cells between the seminiferous tubule to create testosterone in order to create sperm in the seminiferous tubule lining. So this one is correct because these two are both gonads. B and C are the right answer for this question. That was a good one. Let's see, what is this? It says during luteal, that's luteal phase in the menstrual cycle, which of these hormones increase in the production? Remember, during the luteal cycle, an ovarian cycle, okay, ovulation is here. Okay, this is luteal. It's right after ovulation. Ovulation is just a moment happening, and then it immediately becomes luteal phase. Remember, luteal phase happens in the fallopian tube because it's after ovulation, and in ovulation the egg is released to the fallopian tube. So which of these two are actually activated? Which two hormones? In the beginning here, okay, the estrogen is high and it becomes higher over the time until it drops again. But the progesterone is low and then it peaks in the luteal alone. So we have progesterone and we have estrogen. As for the other two, the high level of estrogen in the follicular phase here, it is going to elevate them during a certain time. And let's see, this is FSH. And this is LH. Okay, during a certain time, and they drop back immediately afterwards. Okay, they drop back. This was the graph shown in the book. According to the graph that we studied, estrogen and progesterone are the ones that are increasing. These two get suppressed by a negative feedback through one of these hormones that we're going to find it out later. So here, estrogen alone is not correct. It's not increased alone. LH and FSH are out of question. These are suppressed after a while through what? A negative feedback. So the answer is both progesterone and estrogen. This was our answer, and the graph shows it clearly if you remember it. It's going to make it easier for you to understand it. So for question 51, when does meiosis start in females? Please focus here. So many students create a mistake in this one because it is a bit complicated, considering that meiosis is one process, but in female gamete these processes are happening in with intersections, sometimes years and years between them. Other times that it's not going to be even completed and the egg is going to be discarded before even that happening. Let's see why. We have what? The fetal stage of female. That means the female is in the mom's womb and meiosis starts, okay? The start of meiosis is in fetal stage, okay? So here, actually, I got the answer, but I'm not concerned about that. Let's discover how meiosis is working entirely. Fetal stage, and then we have puberty, after puberty, when they have menstrual cycle, monthly. On monthly basis, we release one egg. Okay, on average, we release one egg. That egg, then the state of meiosis changes if it's ready to ovulate. Other than that, it still stays the same like the fetal stage. As for when it completes the meiosis, we're going to discover this soon. In the fetal stage, meiosis stops at meiosis 1, but which phase? Prophase 1. Okay, since meiosis is divided into 4 more sections, it stops at the first part, okay? As for after puberty on monthly basis, when ovulates, it completes meiosis 1. Okay. What about meiosis 2? Completing only happens after fertilization. So an egg should be penetrated by a sperm in order for it to get induced and complete meiosis 2. Remember, female gametes, all of the eggs are ready while you're still in your mom's womb, okay? And then these are stopped at prophase 1 of meiosis 1. It completes meiosis 1 only if it hits puberty and it's time of the month to get mature. So not all the eggs are going to complete meiosis 1 after puberty, but only the one that is ready to ovulate. Got it? And for completing meiosis 2, this egg needs to be fertilized. That means that most of our eggs doesn't complete meiosis 2 at all. Okay, only the one that becomes babies. That was like a new information probably, but it's an easy one. Please don't make mistakes here and write these notes for yourself. So for question 52, it's related back to question 50. We're now going to know who stopped the production of FSH and LH here. Since we are going to blame it onto somebody, we know that the 2 hormones remained in the luteal phase were progesterone and estrogen, so it has nothing to do with FSH. It's not going to stop itself. Are they doing it together or one of them? Let's see. The idea behind FSH is to prepare an ovum and make it mature. And after it gets mature, the LH comes in the picture and make it ovulate. If both these actions are complete, do we need them? No, we don't need FSH and LH anymore. And how do we know these actions were completed and we confirm it? It's because of the production of progesterone. This is our answer. Progesterone will not be produced unless corpus luteum was made, which is an indication of a successful ovulation. That's why our choice is going to be progesterone. This is the reason why these 2 are going to lower down in the luteal phase. As for this question, placenta, if you see, placenta have some descriptions. Let's see which one of these matches the description. Placenta is a temporary organ. Actually, it's right. You don't have this normally, only during pregnancy. So this is a correct answer. Okay. It's created by chorionic villi. Yes, the chorionic membrane is one of the 4 membranes of the embryo. It's creating these projection that looks like that. It's going to intervene into the uterus lining and create the placenta. So the uterine lining with the chorionic villi, together they create what? The placenta. That's how we know if this is right and this is right and this is right, D was our correct answer. I hope you know these 3 are correct about placenta. Let's see. We're heading toward question 54. Okay, this is not working. Let's solve it like that. It says in the umbilical cord, okay, again, if this is the uterus and the baby is inside here, that baby needs to connect with the mom through this structure called umbilical cord. Now, umbilical cord is diffusing blood from the mom and the baby. It's exchanged between them. So what is inside it? First of all, we should know that umbilical cord is made of one big vein and 2 arteries that are surrounding it. Okay, what are these? Artery. 2, 1. Let's cross them out just based on that. 2 artery, okay, I'm gonna keep that one. Two vein, no, we don't have two vein. One artery, we don't have that. Let's check if this is right. Two arteries that transport oxygenated blood. That's incorrect. The umbilical cord artery is just like the pulmonary vein. Both of them have deoxygenated blood in them. Opposite of that, the vein has the oxygenated blood inside it. So this is not correct either. The answer is none of the above is correct. Okay, we have two arteries having the deoxygenated blood and one vein with oxygenated blood. That's the mom sending it to the baby. And it's full of nutrition, of course. The last question for this chapter, you could follow me on TikTok and message me on Telegram. Better yet, comment down below this video for me to see it in order to answer your questions. Let's finish it with this one. It says, which hormone initiate birth? A lot of students made mistake in this question when I brought it back in our exam. It says oxytocin, estrogen, and prostaglandin. I know they come like a package and you think, oh, I saw them together, so I'm going to choose D. But in reality, initiation means the start of birth. Which one is deciding is prostaglandin, not all of them, okay? Prostaglandin, and it's made by the cells of the mom and the baby at the same time. But when did we hear all three together? It's the one during, after the initiation. It's the whole process of the giving birth. The contraction of muscle happens because of all these three together. So instead, if I said which one is inducing contraction, you could have chosen all of them. Thank you for listening to our video. I'll see you in our last video and have a nice day.